Hello everyone, welcome to the SR Mass Learning channel. In this video, we are going to discuss one more topic from the chapter functions. So in this, the subtopic is least integer function. Least integer function. So this is very small topic, but very useful topic for the functions chapter. So in my previous videos, we discussed about the greatest integer function. So for that, to completely reverse this one, least integer function. So greatest integer function we are denoted with the box of x, and here we discussed in the previous videos. If I'll substitute something 0.23 like this, so the number will be output integral value we will get, that is lesser than or equal to this one. So we'll get 0. Like if 1.23 means 1 or 1.9 also equal to 1. So like this we got. When it comes to the least integer function, so generally it is denoted with some y is equal to open brackets of x. So open brackets of x. Here, this is also equal to box of x. But what is the difference between greatest integer function and least integer function is, in greatest integer function, the value will be lesser than or equal to that integral part, means if it is 0.23, you will get the 0. So here, in the least integer function, 0.23 of least integer function will be 1. So see, I'm comparing here what is the greatest integer function. So it is denoted with the cap x box of x. So when I'll substitute 0.23 here, I'll get 0. When I'll substitute 0.23 here, I'll get 1 in least integer function. So this is the difference between these two. So if a few more examples, if I want to take here, so I can take like minus 8.0725. So I'll get minus 8. So when I'll come to the g.i.f, so minus 8.0725, so will be minus 9. So like this, minus 0.6, here it will be 0, greater than this value. Minus 0.6 in the greatest integer function is minus 1. So this is the way how we will define the least integer function. So and how can we compare the g.i.f, greatest integer function, and LIF, least integer function. So we should remember clearly here, greatest integer function is denoted with the box of x, closed brackets of x. Least integer function will be denoted with open brackets of x. So these are the difference. So how can we symbolically, how can we say is, if least integer function of x is equal to n, then x is less than or equal to n plus 1, greater than n. So this is the way how we will denote this one, where n belongs to integers. So how it will be the graph of least integer function is, so if I take the coordinate axis, let's we think this is the x-axis and this is y-axis. So let's we think this is 0, some 1, 2, 3, 4, and 1, 2, 3, 4. This is y-axis. So this is x-axis. So minus 1, minus 2, minus 3, minus 4. In the greatest integer function, see, greatest integer function graph I will draw with the red color one. So here 0 to 1 we will get 0 only. Here it is closed, and again at 1 it will become 1, 1 to 2 it will be like this. Next jump to next. So this is the g.i.f graph. So this is the g.i.f graph. So when you will see LIF graph, means the least integer function. So I will draw with the blue color. So here, so when 0 to 1, 0 to 1, so at 0 it will rise to 1. So entire 0 to 1 will become 1 only. Then it will jump to 2. So like this it will be. So just completely opposite to this one. So this is like this. So here it is closed, open, here it is closed. So open, closed, like this. The graph of least integer function. So just reverse of this one. So this blue color denotes, blue is graph of least integer function. Graph of least integer function. So red color denotes So here this red color denotes graph of red color denotes graph of greatest integer functions. Greatest integer function. So hope you understand clearly what is the difference between least integer function and greatest integer function. So here we have the few properties for least integer functions also. So let's we discuss that least integer function properties. So here we have properties of LIF means least integer function. So here I'm not going to give any examples. Directly we can let's we see what are the properties. So least integer function of x is equal to x, which is also equal to box of x. This holds when x belongs to integers. And point number 2 is least integer function of x plus I is equal to box of x plus I. So which is equal to least integer function of x plus I, where x belongs to integers. And the third property we have minus of x will be minus least integer function of x if x belongs to integer, and a minus of x plus 1 if x not belongs to integer. So here we will get the two different cases. And the property number 4 is least integer function of x minus least integer function of x will become 2 least integer of x if x belongs to integer, and 2 times of least integer function of x minus 1 if x not belongs to integers. So these are the two different cases here. Next, we have one more property, that least integer function of x plus 1 by n plus x plus 2 by n, like how we have the in greatest integer function. In similar way, we have x plus n minus 1 by n is equal to box of, least integer function of nx plus n minus 1, where n belongs to natural numbers. So these are the different properties we have. So hope you understand clearly what is the least integer function and what is the difference between least integer function and greatest integer function. So our next topic is fractional part of a function. Fractional part of a function. So what is mean by fractional part of a function? Fractional part function. So what is this fractional part of function is? Whatever you will substitute the value of x, so you'll get output as a fractional number. So generally it is denoted with y is equal to flower brackets of x. Here this flower brackets of x indicates fractional part of x. So generally this can be written as y is equal to x minus box of x. What it means is, for example, x value if I'll take 1.232, so box of x will become what? 1. So when I'll subtract these two, means x minus box of x, so that is the 1.232 minus box of 1.232, so that is the 1.232 minus 1, which is 0.232, which is nothing but box of x value. So that means in box of x, if I substitute 1.232, I'll get output as a 0.232 only. So this is the way how we will try to understand what is the fractional part of a function, fractional part function. So here is the explanation how we can write. So therefore, fractional part of x we can write in many cases x minus box of x, x minus box of x. So here we have few properties for this. So property number 1. So properties we have. So property number 1 is fractional part of x is equal to x if x is lies between 0 and 1, less than 1, greater than or equal to 0. So fractional part of x is 0 if x is belongs to an integer. X is belongs to it. That means if x is equal to 1, so what will be there? Here we can write 1.000 like this, right? So its fractional part will be 0 only. So that's what the property here. So fractional part of minus x is equal to 1 minus fractional part of x. So if x not belongs to integer, x not belongs to integer. Next, fractional part of x plus or minus integer. x plus or minus integer, this doesn't matter. It's just a fractional part of x only. So how it will be the graph? What is the graph of fractional part? Graph. So let's see graph of fractional part of a function. So let's think this is the y-axis and this is x-axis. So here this is x o x dash and y o y dash. So 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, -6. So let's think y is 1 and -1. So whatever you will substitute 0 to 1, so it will be fractional part of that value. So 0 to 1 it will be like this graph. So 1 to 2 will be lies between here and 2 to 3. So the graph, whatever you will substitute the values, 2 is 0 only. So everything will be like this. This is the graph of fractional part of a function. So this is the graph. So hope you understand clearly. So in this video, we discuss about the least integer function, and we compare the least integer function and the greatest integer function, and we discussed about the fractional part of a function now. Fractional part of a function, and there is a small topic in this functions, types of functions. So that is nothing but signum function. So let's have a discussion about the signum function of x. So let's discuss signum function. So what is the signum function? Is generally we don't have any separate definition. So signum function usually denoted with sgn of x. So it is defined like this: y is equal to signum of x is equal to mod of x by x or x by mod x. So this is if x not equal to 0, so it will become 1 minus 1. That means when x is greater than 0, when x is less than 0. So when x is equal to 0, so that means the signum function will become 0. So here only three outputs will get. One is plus 1 for x greater than 0, -1 for x less than 0, and 0 for x is equal to 0. So if you look at the graph of this one, so the graph of this one will be like this. So this is x-axis, let's think xo, x dash, yo, y dash. So for x greater than 0, it will be at 1. For x greater than 0, this is y is equal to 1. For x less than 0, it is y is equal to -1, and x is equal to 0, the y value also 0. So this is the signum function graph. So it will be like this. So hope you understand clearly. So thanks for watching my video. So please support to me to do the more videos and to achieve my goals to teach the all IIT topics in small parts. And we will discuss more number of problems and very good problems. So initially I started with the basics, how to understand the different topics. If you'll cooperate with me and please subscribe, and if you'll share to your friends, if you'll support to my channel, definitely I'll give my best, and I will give the best questions as your videos with complete explanation. So thank you all for watching my videos. Please do subscribe.